Welcome to mathematics class. Application of differentiation part 2. Long answer type questions. Find two positive numbers whose sum is 15 so that the sum of their squares is minimum. Sum of their squares is minimum. Let one of the number be x and the other number becomes 15 minus x. Sum of them is 15. So if one number is x, the other number, second number becomes 15 minus x. And the condition, sum of the squares should be minimum. So the condition to be sum of the squares is minimum. Let it be a function of x. First number square, second square. So differentiating with respect to x, f dash x, x square differentiation is 2x, and this is 2 into 15 minus x, and minus x differentiation is minus 1, 2x, 2 into minus 1, minus 2 into 15, minus 30, minus 2 into x, plus 2x, 2x plus 2x, 4x minus 30. This is the first differentiation of the given condition. Let us call it as 2. Again, differentiating with respect to x, that is double dash, second derivative. 4x differentiation is 4, 30 differentiation is 0, constant differentiation. So double dash x is 4. Equation 3. Now, for maximum or minimum, f dash x should be equal to 0. The first derivative should become 0. That is equation 2, 4x minus 30 is equal to 0. From equation 1, that is 4x minus 30 should become 0. 4x is equal to 30. X is equal to 30 by 4. That is 15 by 2. X value is 15 by 2. For maximum or minimum is at x is equal to 15 by 2. These are the stationary points. Now, f double dash 15 by 2, since f double dash x is 4, it is a constant function. So substituting x value 15 by 2, that is 4. So the 4 is greater than 0. Therefore, f double dash 15 by 2 is greater than 0. If double dash is greater than 0, then it is maximum at that minimum. If greater than 0, it is minimum. If less than 0, it is maximum. Therefore, fx is minimum at x is equal to 15 by 2. We want minimum. The condition is minimum. So the first number is 15 by 2. Therefore, the other number 15 minus x. So 15 minus x value 15 by 2, that is 30 minus 15, 15 by 2. 15 to the 30, we'll get 15 by 2. So therefore, the two numbers are first number 15 by 2 and second number also 15 by 2. Similar problem, only the sum is 16. Almost same. In this one, the sum is 15. Here, the sum is 16. Let us practice this also. Same problem, only instead of 15, here 16 is there. Let the first number be x. The second number becomes 16 minus x. So that the sum of the two numbers is 16. So if one is x, other becomes 16 minus x. Now the condition, sum of the squares should be minimum. So let the function be f of x. Sum of the squares should be minimum. Now differentiate with respect to x. X square differentiation 2x. So this is 16 minus x whole square is 2x, and x differentiation is 1 minus x differentiation is minus 1. 2x, 2 into minus 1 minus 2 into 16. 32 minus 2 into minus plus 2x. 2x, 2x, 4x minus 32 is the first derivative. This becomes 0. Again differentiating with respect to x, that is f double dash. 4x differentiation is 4. 32 differentiation is 0. That is 4. F double dash x is 4. Now for maximum or minimum, f dash should become 0. That is 4x minus 32 is 0. 4x is equal to 32. X is equal to 32 by 4. That is 8. X value. Substituting this x value in f double dash. F double dash 8. Since it is a constant, so f double dash x is equal to 4. So in place of x 8, even though value does not change, it is independent of x right side. 4 is greater than 0. F double dash x is greater than 0. Therefore, the fx is, the function is minimum at x is equal to 8. Therefore, the other number, the second number, (16 minus x), 16 minus 8 is 8. Therefore, the two numbers are 8, 8, so that the sum is 16 and the squares of the numbers, sum of the squares of the numbers should be minimum. Both the problems are similar, just one number is different. Let us practice one more problem. In maximum minima, it is also very important problem. If the curved surface area of right circular cylinder inscribed in a sphere of radius r is maximum, then show that height of the cylinder is root 2 r. Now, a sphere of radius small r is given. Let us, so this is a sphere, and a cylinder is inscribed in the sphere. A right cylinder is inscribed. Let this be O, this is A, and this is B. This is small r, and the radius of the cylinder is capital R, and the height of the cylinder is h, and half of the height is h by 2. So O A B is a right triangle where OB is the hypotenuse, this is smaller, it is the radius of the sphere, and AB is the radius of cylinder, capital R, and OA height, half of the height of the cylinder. If the height is and it is h by 2, half. In triangle OAB, OB square is equal to OA square plus Pythagoras theorem. Square of the hypotenuse is the sum of the squares of the other two sides. That is, r square is equal to r square plus h square by 4. So from this, capital R square is equal to small r square minus h square by 4. Now we have to maximize, the condition is curved surface area. We have to maximize the curved surface area. Curved surface area of cylinder is 2 pi r h. Squaring it, taking f of, this is capital R, four pi square r square h square. Substituting r square value from 1, substituting r square value from 1, this is the function of h. Height we have to decide 4 pi square h square. Now r square value is r square minus h square by 4. 4 pi are constants. Multiplying with h square, this is r square, h square, h square into h square, h power 4 by 4. Now differentiating with respect to h, f dash h is equal to 4 pi square, r also constant. This is given. Radius of the sphere is smaller, so it is constant, it is fixed. R is constant, you take it as constant. And h square differentiation is 2h, and h power 4 differentiation is 4, h cube by 4 is there, 4 will get cancelled. R square is constant, r is constant, r square also constant. Now 4 pi square 2 r square h minus h cube. This is, let us call it as equation 2. For maximum or minimum, this first derivative should become 0. Therefore, 4 pi square 2 r square h minus h cube should become 0. 4 pi bringing right side will become 0 by 4 pi, that is 0. So it is r square h minus h cube is equal to 0 by 4 pi square, that is 0. Taking h common, 2 r square minus h square is equal to 0. And bringing h right side, h square 2r square is equal to h square, and that is h is equal to under root 2r square, that is root 2r. Differentiating with respect to h, f double dash h, that becomes f double dash h. Again differentiating this one, equation 2, with respect to h, 4 pi square 2 r square this is 4 pi square is constant as it is, and R square is also constant. H differentiation is 1. H cube is 3h square. Now substituting h value root 2r, or h square is equal to 2r square. In this, four pi square 2r square minus 3 into 2r square. That is 4 pi square 2r square minus 6r square minus 6 to minus 4r square. That is minus 16 pi square r square, which is negative value. That is f double dash root 2r, that is less than 0. Therefore, f double dash h is less than 0 at h is equal to root 2r. Therefore, if it is less than 0, f of h, the condition function, is maximum at h value root 2r. So therefore, the maximum lateral curved surface area cylinder height is root 2r, inscribed in a sphere. This is also important. All these questions are maxima, minima. First, we have to identify the function which has to be minimized or maximized. For minimum or maximum, the function first derivative should be 0, and solving it, we get the points. At that point, the function value should be minimum or maximum. To know whether it is minimum or maximum, we have to substitute it in its second derivative. If the value in second derivative at that point is less than 0, then it is maximum. The function is maximum at that point. If the second derivative at that point is greater than 0, the function is minimum at that point. So here the second derivative at h value root 2r is less than 0. Therefore, the function is maximum. Here, what is the function? The curved surface area of a cylinder is maximum when the height is root 2r. So, to get a maximum curved surface area out of this sphere inscribed in the sphere, we have to take the height of the cylinder is root 2r. Thank you. Thank you for watching. Practice some more problems from the exercise.